Hello everyone. Today we are going to discuss some important questions of exercise 4.2, and there are some easy questions, there are some tricky questions, and there are some very simple, there are some questions having more number of steps. So I am selecting few questions, and one such question is question number 5. This is quite interesting questions, and I think you will definitely, when you solve this one, you will obviously love this question. Okay, we are going to solve this. What you have to prove that this determinant, okay, each term is a binomial. You have to show that this is equal to twice of this determinant, and each term of the determinant is a monomial. Okay, how to solve these questions? Okay, to solve these questions, we'll start with the left hand side. Okay, we'll consider this one as left hand side. This is left hand side. Okay, all the terms are binomial. So what I'm going to do is, we'll change R1, we'll add R1 with R1 plus R2 plus R3. I'll tell you the reason why we are going to change R1. R1 plus R2 plus R3. So let us write after this changes. Okay, if I just add R1 plus R2 plus R3, what are you going to get? If we add, there are 2B, there are 2A, there are 2C. So we will get the term as 2A plus B plus C. And similarly, you can write these two terms. What will be these terms? This will be 2P plus Q plus R. Okay. See, obviously you can make it out like what will be the next term, because there are some symmetry. Like here you have seen that there are the 2y, 2z, 2x. So this will be 2x plus y plus z. So we are not changing anything with row 2 and row 3. So this C plus A, R plus P, Z plus X, A plus B, P plus Q, X plus Y. Now what is common in the first row? In the first row, the 2 is common, so we'll take 2 out. The next steps. If we take 2 out in the next steps, so what will be left out? A plus B plus C, then P plus Q plus R, then X plus Y plus Z. Then this is C plus A, R plus P, Z plus X, A plus B, P plus Q, X plus Y. Okay, these are the terms. So what is the big changes? What is the basic change that you have seen in this determinant? Here, first row, instead of binomial, you are converting to the trinomial. Okay, this will definitely help us a lot. Okay, let's go ahead for the next step. So what is the next steps we are going to do is, we'll be changing R1, we'll be subtracting R1 from R3. Why are we doing that? Because you have seen that here A plus B plus C and here is A plus B. If we subtract A plus B plus C from A plus B, we'll get a single term, monomial. So we need that only. So I'm going to change this. So what operation you are going to use? We are going to change R1 in terms of third row. You don't forget, when you use a particular property, don't try to forget to write that. So A plus B plus C minus A minus B. So we are going to get here C. Okay. Next, B plus C. If you add A plus B plus C, already 2 A plus B plus C was there. You have taken 2 common. So A plus B plus C is there. If you subtract A plus B and A plus B will get cancelled, you will get C. Now if you subtract this from this, P and Q will be cancelled out, you will get only R. Here X, Y will get cancelled out, you will get only Z. These are the terms. There is no changes in the row 2 and row 3. So this will be C plus A, R plus P and Z plus X. Then A plus B, P plus Q, X plus Y. Okay, you have seen that there are initially it was a binomial. With the help of application of a property, it's a trinomial. And when there is a trinomial and a binomial, it is very easy to convert to a monomial. So we got CRJ. Now, what is the next step? Now please compare with the terms. Like we'll be comparing this C plus A with C, this term, C plus A, C. Now if you subtract R2 from R1, so here A will be left out. Similarly, R plus P, if you subtract from this, so P will be left out. So if you utilize this two row, again you will get a monomial in the second row. So row wise we will be converting the binomial to monomial, because we know the right hand side, in the right hand side determinant, each and every term is a monomial. So that is our objective. Okay. Next step. What is the next step? Next step we are going to change R2. R2 we are going to change as R2 minus R1. R2 minus R1. So R2 minus R1 we are going to write in this way. So we have changed R2. Remember this? We have going to change R2. So obviously the first row will remain as it is. C, R, J. So if you subtract C plus A from C, so it will be A, and R plus P minus R, it will be P, and Z plus X minus Z, it will be only X. So X will be left out. Yes, you are very, very close to the answer now. X plus Y. Why I have selected this question? Because I have seen that in the many other cases when solving this questions that students make a mistake because they use wrong property sometime. Okay, so we can see that how logically this question can be solved. Let us go ahead. Next. So here there was a 2, we list out that 2, so here 2 will be there. Okay. Initially there was 2, we took 2 common, so 2 will continue it writing with 2. Next. 2 is there. So now how will you compare? You will just try to change this row, that is A plus B, P plus Q, X plus Z. So you can compare R2. So we'll use this R3 minus R2. So if you change that, so C, there is no change with the first row, C, R, Z, C, R, Z. So it will be A, P, X, and A plus B minus A. So only B will be left out. So P plus Q minus P, Q will be left out. Then X plus Y minus X, what will be left out? Y. Okay? So finally, you got a determinant on the right hand side. Now let's compare whether this determinant is the answer or not. Okay. So remember one thing, when you use the terms like A, B, C, X, Y, Z, these are always given in an order. Okay. So in some places this 2 was missed out. So I've just written this 2 now because initially we took 2 as common. Let us see that. So since C and D there, so it has to be A, B, C. That means A should go these positions, B should come to this position, C should come to this positions. Let us do this. Let us do one thing. First we are going to interchange row 2 and row 1. If we interchange row 2 and row 1, C will be in the second positions. And then thereafter, when C will be in the second position, there should be one more interchanges between the row 2 and row 3 positions. Then the first element will be, first column element will be A, B, C. That means to change this determinant to the determinant, what is there in the right hand side, there should be 2 changes in the rows, 2 pair of rows to be changes. So we know that for 1 pair of changes in the row, there the determinant gets multiplied by minus sign. If we change 2 pair of changes, then it will be multiplied by a plus sign. So in one go will be changes 2 pair of rows. So therefore we'll be writing the first row as APX, the second row will be writing as BQY, and the third row will be CRJ. Because this concept I explained in the previous video also, that CRJ you bring down to the second positions, APX bring down to the first position. This is step 1, there will be a minus sign. Then again CRJ, what was there in the second row positions, I am shifting this CRJ row to the third position, then BQY will be in the second position. So I have made two pair of row changes here. So it will be multiplied by minus 1 to the power 2. So minus 1 to the power 2 is plus. So you can see that your right hand side determinant should be this. So twice A, B, C, P, Q, R, X, Y, J. And this is the first answer. Okay. We'll move to the next question. The next question will take an easy question, that is from question number 8. There are two questions in question number 8. We'll take question 8.1. Prove that, this is question number 8.1. Prove that 1, 1, 1, A, B, C. 1, 1, A, B, C, A squared, B squared, C squared is equal to A minus B, B minus C, C minus A. Okay, the moment you have seen the questions, okay, you should definitely be happy to see all the ones in the first column. If you have seen the previous video, that I explained that when there will be all the rows or the columns, if entries are 1, I mean if all the entries are 1, then we get a benefit. What's the benefit? Like out of these 2 ones, you can make 2 ones. Out of the 3 ones, 1, 2, 3, you can make 2, 1, 0. Okay. So here what I am going to do is, in the first column, we are going to make 2, 1, 0. So how can you do that? So we'll take this one as left hand side. Okay. So what operation we are going to use it? Since we are going to make this 1, 0, so you can just subtract R2 from R1, and this also you can subtract from R3 from R1. So we are going to use that operations, that is R2 minus R1 and R3 minus R1. So these steps are very, very important. Okay, what will be the next determinant? So there is no change in R1, so you need to write as it is. A squared. So if you subtract 1 minus 1 is 0. Then this is B minus A. And this is B squared minus A squared. So it's 1 minus 1 is 0. And C minus A. And this is C squared minus A squared. C squared minus A squared. So you have seen that. So it's 1A squared. There is no change in the first row. And second row we are subtracting from the first row. 1 minus 1, 0. B minus A. This B minus A. B squared minus A squared. B squared minus A squared. Then third row again we are subtracting from R1. 1 minus 1, 0. C minus A. C minus A. C squared minus A squared. Done. Okay. This is a simple trick. So when you get it questions having all entries 1, so always try to follow this particular method. Remember one thing, here I am making this 2, 1, 0. It's not necessary that always you need to make this 2, 1 fully 0. You can just, out of the 3, 1, you can make any 2, 1, 0. Okay? Yes. Next, what is the next step? Now before you expand this determinant, remember one thing. If there are more steps, more property can be used, please use that. Now you compare this R2. In R2, which element is common? In which term is common in R2? Here's option is B minus A, and since it's 0, you can take any term common. So B squared minus A squared. What is the factorization of B squared minus A squared? It's B plus A, B minus A. That means in R2 there is a term common. What is that? That is B minus A. Similarly, there is a term common in the third row as well. It is C minus A. So therefore, we are going to take B minus A and C minus A common respectively from R2 and R3. So what is the next steps? B minus A and C minus A. So there is no changes in row 1. This will be 0. You have taken B minus A common, so it will be 1. And B squared minus A squared, you have from B squared minus A squared, B minus A you have taken common, so it will be B plus A. And this is 0. This is 1. Then C minus A you have taken common. What is left out? Yes. This is C plus A left out. Now what are the trick you have followed? You are converting to 1, 0. Thereafter you have seen that in a determinant is there more simplification possible? Yes, here it's possible. These are the terms you can take common. After that, okay, this is the simplified determinant. When you get a simplified determinant, you can go for expansion. We are going to expand, so we'll be obviously expand this determinant along the first column. So how to expand? B minus A, C minus A. If we expand along 1, we need to multiply 1 into C plus A. So this will be C plus A, then minus 1 into B plus A. So it will be minus B minus A. So what will be cancelled out? This is A cancel out. B minus A, C minus B. I'm going to write the steps. Okay, what is the final step? I'm going to write. Okay, final step after this is this. B minus A, C minus A, then C minus B. I repeat, this is B minus A, C minus A, C minus B. But remember one thing, that when the questions asked on the terms like ABC, X, Y, Z, P, Q, R, so always they give in an order form. And now it is not coming in order form. But never mind, you can definitely change to that order. B minus A generally occur as A minus B. So we'll change the order. Okay, then A minus B, B minus C. But it is coming as C minus B. So we need to make B minus C. And then the last term is given, it's coming in the right form. Now the question is, can you do that? So B minus A, I have written A minus B. C minus B, I have written B minus C. Okay, generally it's given in the form of A minus B, B minus C, C minus A. So these are the terms are quite natural, it will come like that. Now what? See, B minus A cannot be written as A minus B. The moment I write A minus B, there will be a minus sign. And C minus B, the moment I write B minus A, there will be another minus sign. So both the minus sign, if you multiply, it will be plus. That means if you make the changes of B minus A and C minus B together simultaneously, so this term, the multiplication won't be affected by any sign. So therefore, these two are two equivalent steps. So this is the answer. Okay, this is our simple questions, and we are following certain properties, and we got the answers in less number of steps. Okay, next we are going to solve a sum which is equally important and has got certain tricks. We are going to start that sum. Okay, what is that sum? This is question number 9. Question number 9. What is this questions? Prove that, okay, x, y, z, x, y, z, x squared, y squared, z squared, yz, zx, xy is equal to x minus y, y minus z, z minus x into xy, yz plus zx. See the right hand side. Observe the terms carefully. X, y, z, x square, y square, z square is a second column, and the third column is y, z, zx, xy, and the right hand side is x minus y, y minus z, z minus x, and xy into yz plus zx. We need to do this. Okay. We'll consider this one as left hand side, and we'll remove this side, but remember this is xy, x minus y, y minus z, z minus x, xy, yz, zx. Okay. Let us observe the term here. Now when you get a questions in a determinant, and you know that you need to use property, you can't just expand as it is. Okay, because it's not allowed, it's given in the question that use properties and then expansion possible at the last steps. Now if we try to add, say, let us try, say we don't have any idea, so then how to start? So we'll be adding this. Already you add, if we add here, that is R1 plus R2, R3, you'll be getting x plus y plus z. Here you'll be getting something else, x square plus y square plus z square. Here you'll be getting something else. That means we are not going to get any common term. Okay, any term which will help us to solve the questions. Similarly, we'll try for the column method. So if you add column wise, column 1, column 2, column 3, x plus x squared yz, here y plus y squared plus zx, here z plus z squared plus xy. In case you use this property c1 plus c2 plus c3. Okay, this is a way maybe you are thinking about the questions. Okay. Now about the way, it's not working. So then how to shift our focus? Now here what I have seen, this term and this term and this term are very meaningful in these questions. Here yz is there, here zx is there, here xy is there. So in case if we multiply this one by x, it will be xyz. If we multiply this one by y, it will be xyz. If we multiply this one by z, it will be xyz. After getting all xyz in the third column, we can obviously take xyz out. So then what will be left out? All the entries will be 1, and after that I know you can solve the sum. Okay. So what is the steps we are going to follow? We are going to multiply this row, because you know that one element is not allowed to multiply. Either you have to multiply the whole row or whole column. So we are going to multiply the first row by x, second row by y, and third row by z. The reason behind already I explained you, to make this one is xyz, so that you can take xyz out. Remember one thing, when you multiply a row by x, the whole determinant gets multiplied by x. So simply without dividing the determinant by x, you simply can't multiply. So what are the next steps? What are you going to follow? So it will be multiply the first row by x, therefore same time you need to divide the determinant by x. Second row will be multiplying by y, so you need to divide. If you multiply, remember you need to divide. Third row you are going to multiply by z, so you need to divide by z. So now, since the whole determinant you are dividing by x, y, z, so you are allowed to multiply the first, second, third row by x, y, z. So if you multiply, this will be x squared, x cubed, this is x, y, z. So what is the second row? This is y squared, y cubed, then x, y, z. Then what is the third row? Third row is z squared, z cubed, x, y, z. So finally, this is the determinant. Now what is common in the third column? X, y, z. So how can you utilize that? What will be the next steps? I know that steps is coming to your mind. The obvious steps is what? We are going to take x, y, z out from the first column. Okay, now x, y, z was in the denominator. Now we'll be taking x, y, z out. Yes. So it is x squared, x cubed, 1. Next, y squared, y cubed, 1. Z squared, z cubed, 1. Okay. This will get cancelled out. So next is a very common steps. Next steps. What I'm going to do is, okay, next steps, we are using these steps in many other questions. We are going to make this 1 0 and this 1 0. So how can you make this 1 0? That means we will be changes R2 from R1. So obvious steps will be R2, R2 minus R1, R3, R3 minus R1. So please write this R2, R2 minus R1, R3, R3 minus R1. So if we subtract this, there is no changes in the first row. This is x squared, x cubed, 1. If you subtract y squared minus x squared, then y cubed minus x cubed. If you subtract 1 minus 1, it will be 0. The next, we are going to subtract this from the first row, that z squared minus x squared, z squared minus x squared, then z cubed minus x cubed, z cubed minus x cubed, then 1 minus 1, that's 0. Done. Okay. So R2, y squared minus x squared, right? Then y cubed minus x cubed, right? Then 1 minus 1, 0. Next, z squared minus x squared, then z cubed minus x cubed, then 1 minus 1, 0. Now, what will be the next steps? So this question's remaining part is similar to the previous question, that was question number 8. Now before we expand this determinant along the third column, there are some simplifications. I think it's coming to your mind. What is common in the second row? Second row you have a same, this is y square minus x square, this is y cube minus x cube. So obviously y minus x is common there. So we are going to take y minus x common from the second row. What is common in the third row? Third row, z square minus x square, z cube minus x cube. So z minus x is common. So we are going to take common from row 2 and row 3. So what is the next step? The next step is this. Y minus x we take common from the row 2 and z minus x we take common from row 3. So what is left out? This is x squared, this is x cubed, this is 1. So if we take y minus x is common, so y plus x is left out. Now if we take y minus x common, so what is the next steps? So it will be y squared plus yx plus x squared. Now from, okay, it will be 0. Now from here z minus x you have taken common, so it will be z plus x. Now from z cube minus x cube, what you have taken common? Z minus x you have taken common, so it will be z squared zx plus x squared. Okay, done? And this is 0. Yes, these are determinant. So this almost simplified. Okay, almost simplified. Now we are going to expand this determinant. Okay, we are going to expand this determinant. So how to expand this? So we expanding this determinant we are going to expand along the third column. So if we expand along the third column, what are the steps? Y minus x and z minus x. So if we expand along the third column, okay, this is what we are going to do is we are going to multiply this element with this, that is y plus x into z squared plus zx plus x squared. So there will be second bracket. Okay. So we are expanding along column 3. So first element is 1. You don't need to multiply with 0 and 0, because if you expand along 0 this element, along this element, both the terms will be 0. You need to only expand along 1. So when you expand along 1, you know that this column and this row and this column to be removed. Okay. Then you need to multiply y plus x into this minus z plus x into this. So y plus x into z squared plus zx plus x squared minus z plus x, then multiply by y squared plus yx plus x squared. Done. We are going to simplify now. So how to simplify? Okay, we are going to simplify this y minus x, z minus x. We'll multiply the terms. If you multiply, it will be yz squared, yz squared, then yzx. That means plus x, y, z. Okay? Then y into x squared plus y into x squared. Then you multiply with x. Then x, z squared, then x, z, x. That means z plus z x squared. Then you write x into x squared. So plus x cubed. Then multiply by these terms. Okay? Here z plus x multiplied by this trinomial. So all of there are 6 terms will be there, but it's multiplied, each and every term multiplied by minus sign. So all terms will be negative here. So minus z squared. The next term is z xy. So it will be minus x y z. Next term will be minus z x squared. Then come to x y squared minus x y squared. Then multiply x yx. So it will be minus y x squared. And the last term is minus x cubed. Yes. Altogether there should be 12 terms. Okay. Now let us see what other terms can be cancelled out. So xyz and xyz will get cancelled out. Yz squared. Yz squared. Is there any terms yz squared? You need to see that. Next coming in yx squared. Yx squared plus yx squared. So this term yx squared will get cancelled out. Then next xz squared. X, is there any terms consisting of xz squared? Here zx squared is there. Here plus zx squared minus zx squared. It will get cancelled out. Okay. This plus x cubed and minus x cubed. got cancelled out. How many terms are left out? Yz square plus xz square minus zy square minus xy square. These terms are all different terms. So we need to write these terms. Y minus x, z minus x, yz square plus x z square minus zy square minus xy square. Yes. Finally it got simplified. So only 1-2 steps are there. Okay. What are the next steps? Y minus x, z minus x. Now we are trying to factorize this. How to factorize? Yz square. Take one positive terms, one negative term. Yz square, zy square. Here yz common. So we will be taking. So it's selecting first term and the third term. What is common? Yz. Both are common. So we will be taking yz common. Yz common. What will be left out? Z. From here, y will be left out. Now consider these two terms. What is that? Xz square minus xy square. What is common? X is common. So we can take x common. Z square minus y square. Right? Yes. Okay. Now y minus x, z minus x. Now this is a binomial. Here z minus y, here z square minus y square. In z square minus y square, if you factorize, you get a term z minus y. It means from this you can take, from this term you can take z minus y out. So we'll take z minus y out. If we take z minus y out, what will be left out here? Yz will be left out. And here what will be left out? Here, if you take z minus y out, z plus y will be left out. And z plus y, if you multiply it by x, so it will be xz. Okay, z plus y into x, xz into xy. Okay, so finally, y minus x, z minus x, and z minus y into yz plus zx plus xy. Here, only this simplifications has got certain steps. So you can't help it. There will be some questions. You will have certain steps, but you need to go ahead, and it's not difficult, it's simple. But remember, the cancellations, you need to be little careful. Now, have you seen that? Like the previous questions, here also the order we are not getting the way it's there in the answer. So y minus x you generally don't get. If I have not seen the answer also, you can just make it out. Like y minus x should be x minus y. I'll make it x minus y. But remember this, when I change an order, I know that there should be changes of two orders. So x minus y, and next term is, this should not be z minus y, it has to be y minus z. So when I am making a changes, I am making a changes on this term and this term. That means if you change two order, so minus into minus, that means this whole terms will get multiplied by only plus. So last term there is no changes, j minus x. X minus y, y minus z, z minus x into, so xy plus yz plus zx would be the right hand side. So have you seen that? That's determinant questions. If you are practicing questions using the properties, they are quite interesting and you can easily definitely get marks, and okay, it should not be any problem with the topic. Next, we are going to solve one more questions from the exercise. Okay, this is question number 12. What do you have to prove? Question 12. Question 12. Prove that 1x x squared 1x x squared 1 is equal to 1 minus x cube whole square. You need to solve these questions. How to solve this? Starting part, it seems to be very simple in these questions. I hope you can just start the questions, how to solve the steps. Here you have seen that 1x squared. So if you change R1, that means if you change R1 with the help of R2, R3, what is the first element? You are going to get 1 plus x square x. Here also you are getting x plus 1 plus x square. Here also you are going to get x square plus x plus 1. That means if we change R1, that is R1 plus R2 plus R3, this element for all each and every element of the first row will be same, that is 1 plus x squared. So obviously you can go with that steps. So if a term is common in a particular first row or column, that will be taken out, then we'll be getting all the entries will be 1, 1, 1. So here we can apply R1 plus R2 plus R3. That means you can apply R1 plus R2 plus R3. Okay. I know like there will be a question in your mind in this moment that why we don't use column operations here. So if you use say C1 plus C2 plus C3, what happens? So if you use C1, if you change C1 plus C2 plus C3, what are you going to get? 1 plus x squared. Here also we are going to get 1 plus x squared. Here also 1 plus x squared. So in these questions, okay, so initially you can start with this R1 implies R1 plus R2 R3 or C1 plus C2 plus C3. Any one of the operations you can start. And remember one thing in determinant, throughout the steps, it's not necessary that you have to only use row operations. You can shift from row to column, column to row. So here we are going to start this question, say left hand side is this. Okay, so we'll be using C1 plus C2 plus C3. So if you change the column 1, so we'll be adding this. So first element will be 1 plus x squared. A second element will also be 1 plus x squared. And third element will also be 1 plus x squared. So there is no changes. x1, x squared, x1. There is no changes in column 2 and column 3 positions. So here column 1, each and every element is 1 plus x squared. So what is the very simple next steps? We'll be taking 1 plus x squared out. So if we take 1 plus x squared out, what will be the elements? Here it will be 1, 1, 1. Then there is no changes. Here x, 1, x squared. And here x squared, x, 1. Done? Okay. So next, we are going to follow a very common steps. So we are going to make this 2, 1, 0. That means this 2 and 3 we will make it 0. Can you do that? For that we are going to use the operations, that is R2 minus R1, then R3 minus R1. This is very common steps. So 1 plus x squared is there. Then it will be 1 x squared, and if you subtract it will be 0, and it will be 1 minus x, and this will be x minus x squared. Then it will be 1 minus 1, 0, x squared minus x, then it will be 1 minus x squared. Done. Okay. Next, what is the next steps? What we have done here, we are making this 1, 0. So we are subtracting this one from row 1. 1 minus 1, 0, 1 minus x, 1 minus x minus x squared. Then we are subtracting R3 from R1, 1 minus 1, 0, x squared minus x, 1 minus x squared. Now we directly don't start expansion. Okay, what is the simplification possible? Can you compare these two terms, two rows, R2 and R3? In R2, what is common? You can take 1 minus x common from R2. And what is you can take common from there? From there also you can take 1 minus x common. Because 1 minus x, if you take x common, what will be left out? 1 minus x. Here if you take x common, what will be left out? It will be x minus 1. And here if you factorize 1 minus x squared, what will be left out? 1 plus x, 1 minus x. So naturally, you can take 1 minus x out from the second row as well as from the third row. Okay. So what is the next step? 1 plus x squared is already there. So we'll be taking 1 minus x common from the second row and 1 minus x common from the another 1 minus x common from the third row. That means there will be 2 1 minus x. We have taken common, so 1 minus x whole squared. So it will be 1 x squared. Then this is 0. Observe these terms now very carefully. This is 1 and this is x minus x squared. I'll show you the steps. Okay, here I'll show you the steps. This term is x minus x squared. X minus x squared. So if we take x common, 1 minus x left out. That means x minus x square is a product of x into 1 minus x. So 1 minus x we have taken common, so only x will be left out, right? So come to third row positions. The third row is first element is 0, second element is x square minus x. Okay, I'll show you from this term how can you take 1 minus x common. So x square minus x. So you can take x common, so it will be x minus 1. So here actually x minus 1 is there, but since x minus 1 is there, you can take x minus, if x minus 1 is a factor of x into x minus 1, obviously 1 minus x is also a factor. So if 1 minus x, if you take common from there, so x will be multiplied by minus 1. That means if you take minus x common, so this term, the order will be reversed. So it will be 1 minus x. So if you take 1 minus x common from here, it will be minus x. So remember this, it will be minus x. So this is the important steps. Now from there, 1 minus x you have taken common, so what will be left out? This is 1 minus x squared. That means this is a square minus b square formula. If you take 1 minus x common, 1 plus x will be left out. So this is very important steps. Okay, 1 plus x square into 1 minus x whole square, and these are the remaining terms left out. Now we are very close to the answers. What is our next step? Next step is this. 1 plus x squared 1 minus x whole square. Now we'll be expanding along 1, along the first column. So first column, that means along 1 only will expand because other two entries are 0. So if you expand along 1, so 1 into 1 plus x, so it will be 1 plus x. Then if you multiply this, there will be another minus sign, so it will be plus x squared. Okay, we are getting a very interesting relations now. Okay, what is that? 1 plus x squared. I'll arrange the terms. 1 minus x whole square, I'll just write 1 minus x with this terms. Then I'll write 1 minus x with this. 1 minus x, 1 plus x square. Okay? Yes. Now, if I write in this way, a formula should come to your mind that what is got in class 9. 1 minus x square, 1 I have written with this. 1 minus x I have written with this. Now if I repeat this formula, I think you'll get the answers. 1 minus x, 1 plus x square. What is that? Here also 1 minus x, 1 plus x square. I'll write the steps. Okay. So what is this formula? Can you tell me? This formula, a minus b, a square plus ab plus b square. I hope you remember this formula. This is nothing but a cube plus b cube. This is a cube plus b cube formula. So therefore this is also 1 cube minus x cube formula. That means 1 minus x cube formula. This is also 1 minus x cube formula. So what is the next steps? This is 1 minus x cube, and this is also 1 minus x cube. So finally this is 1 minus x cube whole square. So that's what I say, that this is not very interesting questions. Okay, these are very interesting, very important questions. So I have selected some important questions from the exercise. Okay, and I hope that you will go through this, seriously you go through the video and note down the important steps, solve the sums, and after that we will have left with some more important questions. Okay, we'll be solving those questions in the next video. And thank you so much for watching my video. Until then, bye bye.